a few more of these guys. So we're going to do print max of array, print average of array, return odds of the array 1 to 255, square array, and if we have time, we're going to return the array count greater than y. All right, so let's start off. So def print max of array. All right, so we're going to have to pass in a parameter, and that's going to be the list that we're going to pass in. So let's call it my list. And again, I'm going to use, you'll hear me using array and list. So they're analogous data types. One's for array is in JavaScript, list is in Python, but their behaviors are very, very similar. So I use them interchangeably. And because normally if I were just talking about Python, I would just use list, but because I'm reading these things and they were written for JavaScript, I'm using array and misusing array. So I apologize, but that's what's going on. All right, so if we're going to get a max, basically what we're going to do is we're going to say, hey, let's start our max value, max val equals my list bracket 0. This makes an assumption that we have a 0th element in our list, but then we're just going to go through the rest of the list, and we could have done that with this with range and compared the first element with the 0th element and gone all the way through my list. But why don't we just compare the 0th element as well, just to make it quick and easy. So for element in my list, if, right, so we know it's basically we want to go through the entire list and find the largest one. So if max value is less than element, so this goes through and checks every element in that list, and if that element's greater than max value, then let's just make max value that new element. All right, and then once we're done, we've gone through the entire list, and so now we should be able to just print the max value. All right, again, this makes a bunch of assumptions that we have a 0th element. It also makes the assumption that our elements are all numerical and that we're passing in an array. So 414 to -1. So what we're going to be expecting from this is 414 coming out of it. So let's just see what happens. Oh, max of array is not defined, and it's print max of array. All right, there's 414. And so this print statement, notice there's no return on this. And so we returned nothing, and that's where this none is coming from. But the 414 is coming from this print here. All right, awesome. So we know how to do a sum. We know that the sum is going to be the average is basically going to be the sum of an array divided by the number of elements in the array. And I'm going to do this one kind of quick, but I'm going to do it in a bit of Python syntax. So return average. And we're going to pass in a list again. And all we're going to do is say, hey, let's take sum my list and divide that by len my list. And let's return that. So remember, a return statement, whoa, back up there, buddy, is basically saying, hey, when we invoke this thing, the thing that comes back is return. So let's say Mike equals return average. And we have to pass it a list. And again, we're making all those same assumptions that it's numerical, yada, yada. All right, so here we have 49 and 3. It's going to give us some sort of average, looking to be like 16.333333. One of the things that's going to be interesting about this is we're probably just going to see 16 as our return. So let's see what Mike is. Oh, 16. So this is one of the anomalies of Python, and Python 2 in particular. Division in Python is int division. So if we wanted to make this float division so we get better accuracy, we'd have to say, hey, let's take two floats and divide them and return that. And this gives us 16.3333. All right, cool. All right, but that's the average. We know how to sum things already. We could have just done a sum for a 4-element in loop. We could have gotten the length of the list the same way and done the division that way. but we didn't. So I just want to throw a little bit of Python stuff. All right, so return odds of an array. So this one is, the goal of it is to basically build out a new array. And so return odds array, and we're going to give it nothing. So all we want to do is return a new array. So array, let's start off as an empty list. So this R value is equal to an empty list. And we know how to get all the odds. But kind of the cool thing about range is we should just be able to say range 1, 255, well, 256, and have a step of 2. All right, and then return array. So let's print return odds and see what happens. So it's returning an array, and range generates an array. And there we go. Right. The other way that this was kind of intended was using array.append. So array.append is if we said, hey, let's add on, and we want to go up to 257. Now we'd add this 257 here. Hopefully you saw that pop up. So append is how to add an individual element. So we could have gone and said, hey, and done basically this for loop where we were printing out the different odd elements, like here. We could have said every time this happens, array.append I. All right, cool. Square values of the array. Let's do that one next. So this is something that's called list comprehension in Python. So square array values. And again, sorry about the whole list array kerfuffle. All right, so what we're going to do is we're going to say array is equal to, and we're going to say use this cool thing called list comprehension. Basically, we're going to take every element in the array, and we're going to multiply it and take it to the power of 2. So let's call this element. So this double star is power in Python. So this is squared. So element squared for element in array. Again, it makes a lot of the same assumptions that it's numerical. I mean, that's an array. That's actually a list in there. And return array. All right, so there's our awesome square values. So let's print square values, square array values. And let's pass it in -4, which should be 16, 3, which should be 9, and there we go, 16 and 9. Boom. All right. So I guess we can do maybe one more. So return array count greater than y. So, oops. Def return count greater than y, greater than y. And here's our array, here's our y value. All right, so what this is basically saying is we can pass it in an array, and we're going to compare each element of that array to y, and every time the element in the array is greater than y, we're going to increment a count. So that means we need a count. So count equals 0, because nothing's greater than y yet. And then we basically go for element in the array if y is less than element, count plus equals 1. And then we're going to return the count. Cool. All right, so let's just print it. So print, and remember, when I invoke this thing, I need to pass it an array, and that could be a variable that we've declared as a list somewhere else. Let's do that. So our list equals 1, 3, 7, 11, 21, 4. All right, so our list. So we're going to pass in our list as the first argument, and we're going to pass in 3 as the second argument. So that's going to be our list becomes array, and our list was this list. So now inside of this function, array is this nice fat list. Well, it's not very fat, but all right. And the expectation that we should see is 1, 2, 3, 4 as our result, because we are returning count. And there it is, 4. Cool. All right, stopping that one.